All right, good afternoon, everyone. We're going to go ahead and start into our discussion on ions. Actually, the main question being, how do we form ions? What causes an ion to form, and how will we use this information as we continue going forward? To first start to answer this question, we answer by saying an ion is simply a positive or negatively charged atom. Now, the next couple of slides that we're going to go through, we're going to actually discover why is it that it is positively charged or negatively charged. What happens that's going to cause this charge to form? So the first question is, what charge does an element have if it loses an electron? Now, if it loses an electron, we're going to end up with a positive charge. If you remember when we discussed about the structure of the atom, we found that there's usually the same number of protons and electrons. Protons, of course, with a positive charge, and electrons with a negative charge. As long as these numbers are equal, we have what we call a neutral atom. But if we lose one electron, now we're actually going to have one more positive charge than we do negative charge. This will give the overall atom a positive charge, a positive effective charge. Now, what type of elements we usually go through this? Usually it's going to be metals that we're going to run into. And we'll look at and see that depending on how many electrons they lose, that'll actually tell us what the overall charge will be. Some will lose just one, some will lose more, even sometimes up to 4 or 5. And we'll explain a little bit further as we continue on going. Now, what about if the element gains an electron? So before, go back to our same picture, we said if I had the same amount, we're neutral. Now we're saying I'm going to gain, or I'm going to have one extra electron. This should give our overall atom a negative charge, because now it has one more negative charge than positive. This is going to be the case that we run into for our nonmetals. Now, as we look at our different elements, we have to write what's called an ion symbol. This ion symbol is letting anyone know who looks at our paper or looks at our work that we don't have a stable ion or a neutral ion, but it actually has a charge. It's lost some material. So the first thing that we're going to do is we're going to identify the element that we're going to work with here. In this case, we're going to use sodium. Now, we'll just go straight to the symbol on the periodic table and find it, and we know that it's Na. Great. Now, the next thing we have to do is say what the charge is going to be. Because sodium is a metal, and we said metals are going to lose electrons, we know that in the end, if it's an ion, it will be a positive charge. So I write my plus sign, and then I say plus the number of electrons that left. How many electrons did I lose in this case? In this case, I will lose 1. Now, some of you may be thinking, okay, why did it lose 1? What is so important about it losing that single electron? And we're going to come to that in just a second. If it happens to lose an electron, we're going to call it a cation. Use the picture here on the side. Most people tend to like cats. I'm kind of partial to dogs, but cation is going to be positive. Versus someone comes up to you and they're talking, they have really bad breath, maybe they have onion breath, that's usually a negative thing. So a negatively charged ion, we're also going to call an anion. Now, throughout the rest of our discussions and our activities, you'll usually hear me refer to cation and anion instead of just saying positive or negatively charged. So you want to make sure that these terms remain in your mind. Now, back to the question that I posed earlier. Why is it that atoms want to lose or gain electrons? And the biggest thing that they want to do is, we say they want to be stable like the noble gases. When we talked about the noble gases, we learned that most of their properties are that they are inert or they don't react. And this is because they have a full outer valence electron shell. They're not interested in bonding or interacting with other molecules so much. Now, the other atoms want to be just like this. If they have that extra electron out there, it's almost like it creates strain in the nucleus. Even though the charge is there, it will be easier and lower in energy if it could just get rid of that electron and become stable like the noble gas that comes before it. Or in the case of our nonmetals, if it just gains one or two more electrons, it'll have that stable feeling and look like the noble gases, and not necessarily want to react. As we continue to go through this, we're going to find that because of this desire to be stable, we're going to end up forming some different compounds, and the ways that we will form them will change up just a little bit. But this is just to give you an idea of what's going on overall with our atoms. Now, what you'll start to notice is, as we look at the periodic table, there are some methods that we can use to actually predict what charge we're going to have. And the way that we usually use is, if you look at the top of the chart on the periodic table, if you can look down here at the bottom, you notice that for each row there's a number and a letter. It says 1A, oops, let me go back, 1A, 2A, and so forth. Now, we're going to use these numbers to our advantage. If it's in group 1A, which means most likely it's a metal, it's going to have a positive 1 charge. We can sort of look at it and begin to predict these without even having to go through and draw out how many electrons are there and so forth. In 2A, it's going to be 2 valence electrons that it's going to get rid of. Now, you notice that we skip through this part. We'll come back to why we do that in just a little bit. But the main reason that main way we're able to use this trick is we focus on what we call our main block elements, or the groups that have an A next to the group number. This will tell us how many valence electrons are there, and therefore how many electrons they would need to gain or lose in order to be like the noble gases. Now, as we get ready to wrap this up, one of the things I want you to realize is, as we look at the periodic table, you're going to start to see many different patterns. So keep on the lookout, so that as you view these patterns, you'll be able to use them to your advantage. One thing that sort of helps everything to make sense in the organization of our periodic table is, most times when we see it in this nice box form. This is how we've grown to understand how it works. But as we continue on, one of the things that you're going to learn is the periodic table really looks more like this. And though it looks very strange, if you're paying attention, you notice that right here, those are our noble gases. Everything else is just sort of folded around. Now, we'll continue this another day. Make sure you write down your questions and let me know if any way I can help you. Have a great day, and I will talk to you in class.